regression from sklearn dot linear underscore model. I need train test split, which I will import from sklearn dot model underscore selection. I need matplotlib. I need pandas. So let's run this cell in order to import all the necessary libraries of Python. Now, the second step is, that I am going to create my own data set. Now I am using the function make underscore classification. Now this is a very good function. It helps us to create our own data set. So what are the input to this function? First of all, I can control the number of samples. So here I am passing number of samples is equals to 200. Now it's up to me whether I want to create 200, 500, 1000 or 2000 sample. So the first input is number of samples. Second input is number of features. Here I want to create 2 features with 200 samples. I want all the features to be informative and I do not want any feature to be redundant or multi-collinear. Therefore, number of redundant feature is 0. I want number of classes is equals to 2. So I want a binary classification. Therefore, I am producing a data set with number of classes is equals to 2. Random state is equals to 42. So I am passing random state is equals to 42. So the advantage of passing random state is that every time I run this cell, I will get the same kind of samples, same samples basically, because the make classification generate the data randomly. If I did not pass random state equals to 42 or random state equals to any other value, it will generate different samples every time I run this cell. If I want same samples to be generated, I have to pass random state equals to some of the value. Here I am using 42. So let's run this cell. So what is happening? This make classification will give me 2 output, X and Y. X are my features and Y are my target variables. So if I want to check the shape, X dot shape, it is 200 by 2 because I have input number of samples is equals to 200 and my number of feature is equals to 2. Therefore, it is 200 by 2. Now I want to check my unique labels. Here I have passes number of classes is equals to, these are basically the labels or the target variables. So if I use np.unique, I want to see how many unique labels I have. So I have 2 classes and the labels are 0 and 1. So in this way, using make underscore classification function, I have generated my own data set and I have seen the size of my feature, which is 200 by 2. And I have seen that I have 2 discrete labels 0 and 1. Now it's time to perform a train test split. Here is the function train underscore test underscore split. So this function need quite a few input parameters. The first is X, that is feature. The second is a target variable, then the test size, and here is a random state equals to 42. So the test size I am using is 0.2. It means out of 200 samples, I am using 20% as a test and remaining 80% as a training. Random state equals to 42. Again, I want that every time I split the data, I should get same number of samples. Okay, let's run this cell to perform train test split. Here I want to see the shape. So out of 200, 160 samples will be used for training and rest 40 will be used for the testing. Now it's time to apply logistic regression. So the first step is that I am going to instantiate logistic regression and I am calling it model. Then I am fitting this model on my training component of a data, that is X train and Y train. So here I have completed the training of the model from the training component of the data. Now it's time to get the probabilities and prediction from X test. Since our model has been trained on the training component, now it is ready to give the probability predictions. So for probability predictions, I am using lr.predict underscore prob A. And here I am passing the testing component of my data. So if I run this cell, I will able to see the probabilities. Let's run this cell. So here I have 40 test sample and I am getting the probability of each sample with respect to class 0 and class 1. If I see first sample, so probabilities are telling me that its chance with class 0 is only 0.03. That is, it is 3% likely that first sample belongs to class 0, and it is approximately 97% that it is with class 1. So according to these two probability values, it means the first sample belongs to class 1. So in each row, one thing is common, that is if I add these two values, that is probability with class 0 and class 1, I will get the sum equals to 1. So the sum of this value and this value is also 1. So the sum of the two values which are present in a row is equals to 1 because these are the probabilities with two classes. If we go to the next sample, it has high probability with class 1. Similarly, if we go to the fifth sample here, it has the high probability with class 0 as compared to class 1. If we go to the last sample, we can see that our last sample belongs to class 0. It has high probability with class 0 as compared to class 1. Now it's time to confirm this. These are the probabilities. Let's get the class predictions. So for class prediction, I am using lr.predict. Here I am getting the class predictions directly from the test data. So I can confirm that my last sample belongs to class 0. Here is the confirmation. Similarly, if I want to see all the 40 samples with their probabilities and class prediction, I have to make a table of these probabilities and these prediction. So for this, if I want to observe them in a single table, I am using pd.dataframe. That is, I am using a function data frame from pandas. So I am creating 3 columns. I need 3 columns. One column for the probabilities with class 0, one column for the probabilities with class 1, and one column with the y predict values. So the first column name is probabilities with class 0. Here I am passing y pred prob, and this 0 means the first column of y pred prob. Here is y pred prob. You can see here is y pred prob. I want all the rows, but I need the first column for class 0 and I need the second column. Since index in Python start from the 0, therefore for first column I need to pass 0. For the second column I need to pass 1. So in this way I have put both the columns in my table. These columns are from ypred.prob, and the third column is the predicted label. The name of the column is the predicted label, and I am getting the values of y prediction, that is these values. So let's run this cell and observe the probabilities. Now we can see that from 0 to 39 we have 40 sample, and this is very informative table. This table is giving us the probability with class 0, probability with class 1, and we can see that since the probability with class 1 is high for the first sample, so the predicted class is 1. So we can see that all these probabilities values are right, and we are getting the predicted class according to the highest probability with respect to class. Here the highest probability is with class 0, so the predicted class is also a 0. Here we can also see that for this sample whose index is 9, so this is our 10th sample, the probability with class 0 is high, so the predicted class is also a class 0. So in this way, using pandas, we have created a table, and we can see that this function is returning a correct values of a probability and the correct value of the predicted class. Now the model has been trained and model has been testing. Now it's time to calculate accuracy. First, we will calculate the accuracy manually to get the understanding. So here I am creating predictions again, and these are my original test labels. So it depends upon how many test labels are exactly predicted by the model that will count the accuracy value. So these are the actual test labels, and these are the label predicted by the model. If all the predictions are correct, that is all ypred is equals to y test. So in this case, what will happen? Our accuracy will be 100%. Let's see how many of them correct. So we can see that there are few false values as well. So how many of them correct? We have to take the sum of those values of predicted which are equal to the original test value. So let's run this cell. So we can see that out of these 40 value, because we know that our test samples has 40 samples, our test data has 40 samples. Out of these 40, 32 samples were classified correctly. So if I want to calculate the accuracy, I have to divide this 32 by 40. So here is the sum 32, which is here. And here I am dividing with the total length of my testing data. So I should get 32 by 40. So 32 by 40 is 0.8. So this is the way of calculating the accuracy manually using ypred and ytest. The other way is that you have ypred and ytest. You can equal them and take the mean which is present in NumPy. And also you can see the accuracy which is equals to 80%. So here I have multiplied the accuracy with 100. That's why I am getting the accuracy into 80%. So 0.8 and 80% are equal. Here is the representation in percentage. So this is also the way of calculating the mean. That is, first you are taking the sum and then you are dividing with the total number of samples. So you can now do it directly using NP-main. Now it's time to create the confusion matrix. We have already calculated the accuracy. Now it's time to create the confusion matrix. So how we will create the confusion matrix? So from sklearn.matrix, we will import confusion matrix function. So in this function, we will pass y test, that is our original testing labels, and y pred, our predicted labels. And if I run this cell, I will get the confusion matrix. Now in the confusion matrix, we have 14, 5, 3, and 18. So we should remember from our theory lecture on confusion matrix that this 14, the first element is a true negative. The second element, this 5, is false positive. Then we have false negative. And this 18 is basically a true positive. So we should remember that if we have a 2 by 2 confusion matrix, the name of element should be remembered, that which is true negative, false negative, and a true positive. Now there is another method of generating a confusion matrix. So here from sklearn, I am importing confusion matrix. Now I am also importing F1 score, precision score, recall score, accuracy score, and confusion matrix display. So here I will calculate the confusion matrix, precision, recall, F1, and I will also plot the confusion matrix, and I will display in the form of figure. So look at this. So I have to run this cell to import all these functions. Now look at this code. Here I am creating the confusion matrix. So the input parameters are always y test and y pred. Here I want to display confusion matrix. So I have to pass confusion matrix is equals to CM, which is the confusion matrix. And I want to display my labels, which are 0 and 1. Here display.plot x6 rotation is equals to 45. On the horizontal axis of the confusion matrix, the labels will be rotated by angle 45 degree. We will see here I am getting the information from the figure, so that I am adjusting the width of the figure equals to 8, and I am also setting the height of the figure equals to 8. So here I am getting the information by get figure function, and then I am setting the width and the height of the confusion matrix which I want to display, and here I am showing this. So let's run this cell and to see the confusion matrix. So we can see that we have values 14, 5, 3, and 8. Now if I want to increase the size of these font especially, so this is the size of the confusion matrix which is adjusted by these two 8. But if I want to increase the size of the font, in that case I am using this here font. So font, the weight of the font is bold. I want a font to be bold. I want the font size to be 15, and here I am passing font is equals to font, and this is my RC parameter in PLT, and we have learned about these RC parameter in our section on Python crash course. So if I run this cell, and now if I run this cell, I can see these values are bold and their size is also better. So here we can see that the predicted label along the x-axis are at the rotation of 45 degree, because we have passed the x6 rotation equals to 45 in our line of code. Now we can confirm that this is 14, 5, 3, and 18. So this was another way of creating the confusion matrix just in the form of matrix, and here I am displaying in the form of figure. So the values are 14, 5, 3, and 18. So we can see that the values are 14, 5, 3, and 18. So this is the same confusion matrix, but this is another way of generating the confusion matrix. Now I need to calculate accuracy, precision, recall, and F1 score. So I have already imported these values. If you can see, I have imported F1 score, precision, recall, and accuracy score. Now I can use this function. So accuracy score, I am calculating the accuracy score. So I need to pass y test and y pred. Normalize is equals to true, that I am not going to calculate the accuracy in percentage. Therefore, normalize is equals to 2. Dot round 3 means I need only 3 places of value after the decimal. Therefore, round is equals to 3. For precision, I am using the function precision score. I am again passing y test and y pred. Here, average is equals to macro. Macro means that this precision value will be the precision value of both the labels. It will be the average of the precision. This precision value will not give me the precision of class 0 or the precision of class 1 or a label 0 or a label 1, but this will be the average of the precision of all the labels. That's why I am passing average is equals to macro. And for precision, I also want to get the values up to 3 places of decimal. The same is for recall score, that I have to pass y-test and y-pred, and average is macro. And for F1 score, I have to pass again y-test and y-pred, and the average is macro. So if I run this cell, I will be able to calculate accuracy, precision, recall, and F1 score. And here I am printing this. So this print will create space. This print space will create space after printing the value of accuracy. Let's run this cell and see all these 4 metrics. So we can see that our accuracy is 0.8, our precision is 0.803, our recall is 0.797, and our F1 score is 0.798. So in this way, we have calculated all the values. So what these values are telling us? These values are telling us that our data set is a unbiased data set. It has equal number of labels for both class 0 and class 1. Therefore, its accuracy and precision and recall and F1 are approximately same. So we have an unbiased and clean data. Therefore, we are getting all these 4 metrics with high values. Now, the another way of observing these values is to print the classification report. So for printing the classification report, I am importing classification report from Scikit-learn.metrics. I am importing classification report. Let's run this cell. And here I am printing the classification report. So my inputs are always y-test and y-pred. Let's run this cell and we can see that this is our classification report. So this is the precision value. If you see, this is the precision of class 0. This is the precision of class 1, and this is average precision. So here we get the average precision because we pass average is equals to macro. But in classification report, we can get the precision, recall, and F1 score of every label. So these two are our labels 0 and 1. So these are the average values: average precision, average recall, and average F1 score. And here is our accuracy. So these are support, and because when we split the data, so 19 out of 40 samples in a testing data belongs to class 0. And when we split the data, so the 21 samples belongs to class 1. So we have total 40 samples. So accuracy is calculated using all 40 samples. Similarly, the precision is also calculated with all 40 samples. Recall is also calculated, and F1 score is also calculated with all 40 samples. So we have total 40 samples in all, because initially we had 200 sample and we split the data into 80-20 ratio, where 20% was the testing sample and 20% of 200 was 40. So this support indicates the number of total sample which we use to calculate these value. So we have 19 samples, test sample for 0 class, and 21 test sample for class 1. Now it's time to plot the ROC curve. So I will import ROC curve display from Scikit-learn.metrics. Here I am setting the figure size of 12 by 8, and I am basically creating a subplot. I need 1 row and 1 column. 1 row and 1 column mean I just need 1 location, because there is 1 ROC curve for this whole data. So the function is ROC curve display dot from predictions. So we are calculating from the prediction. So I am passing the first input parameter is y-test, then y-pred, drop intermediate is equals to false. So it means I am not going to drop any of the samples. I want my ROC curve to include all the samples. Here axis is equals to x. Here I have defined the axis where I will plot this ROC curve. So axis is equals to axis, line width is equals to 3, and color is magenta. Let's run this cell and see ROC curve. So this is our ROC curve, and we know from our theory lecture that ROC curve is the curve between false positive and true positive. So here we can see that it is the curve between a false positive and a true positive. And inside or under this curve, area under the curve, AUC is standing for area under the curve. And you can see that area under the curve is 0.8 or 80%. So this area under the curve basically representing our precision value, which is also 0.8. So we know from the theory that precision depends upon all the positive labels, because it has the equation in the numerator. It has a true positive divided by true positive plus false positive. So precision is only looking for the positive labels, whether they are true or false. So that's why if we plot a curve between a false positive and a true positive, the value which we are getting is the precision. So this is our ROC curve, and area under the ROC curve is 0.8, which is representative of the precision of the model. So in this project, we learn how to train and test our logistic regression model. The most important thing which we learn in this project is how to evaluate the model by calculating confusion matrix, precision, recall, F1 score, and the accuracy. And finally, we learn how to plot ROC curve. So I hope you understood everything of this project. Thanks for listening, and I will see you in the next lecture.